see, we talked about multiplying and reducing fractions, and the key is the reducing part, right? The important part is to factor first. One thing that's really nice in algebra and math in general is if you can see similarities among problems. Like even though these two problems here look really different, if you approach them the same way, you look at them, there really isn't, you treat them exactly the same way. The way you would reduce 15 over 21 is exactly the way you would reduce this fraction here. What do you do first? You factor 3 times 5, 3 times 7. We can say cancel the 3's. What we really are talking about is removing factors of 1, right? So the answer is 5/7. Well, let's do the same thing. The first step is to factor. Now the way you factor might be a little different. Here we're going to have to use the distributive law on both of these, right? On the top you factor a 3x out of each of these, so you have 3x times y plus 2. On the bottom you have 2 times y plus 2. Well, just as you could cancel these 3's, they form a 1. Well, what's going to form the factor of 1 here? It's the y plus 2's. So the answer is 3x over 2. So I'm saying don't look at these as being that different, really. All right, let's keep going here. So we're moving towards the direction of starting to talk about adding fractions. We're not going to do that on this problem set, but on the next one we will. But let's look at this problem. We have 5 over 5 times 7 over 9. What does that equal? Let's see, that equals 35 over 45, right? So the question I have to ask you is, does 7/9 equal 35 over 45? Does 7/9 equal this? Are they the same? And the answer is yes, because you just multiplied 7/9 by 1. 5 over 5 is 1, right? When you multiply by 1, it might change the way it looks, but it has the same value. So yes, these are equal. In fact, we say these two fractions are equivalent, which means they have the same value. I like to think of it as pizza. If you have 3/4 of a pizza, but then you cut each slice into half, you might have 6/8 of a pizza. It's still the same amount of pizza, it's just more slices. So 6/8 and 3/4 are equivalent, just like 7/9 and 35/45 are equivalent fractions. They have the same value. Now, so we're going to start doing that. That's going to help us add fractions in the next problem set. But here we go back to making open sentences into true closed sentences. 3/4 equals what over 12? Well, you want an equivalent fraction that instead of having 4 on the denominator has 12. And from what we talked about earlier, if you multiply by 1, it doesn't change the value of the fraction. So what did you multiply 4 by? You multiplied 4 by 3. So as long as you multiply the top by 3, the fraction is equivalent. You see, 3/4 is equivalent to 9 over 12. That's how you do it. Whatever you multiply 1 by, you have to multiply the other by the same thing, because that way you're just multiplying by 1. See how it works? So what has to go in the box? What do you multiply 9 by to get 45? Let's see, 5. So as long as you multiply the top by the same thing, it's going to be equivalent. So it'd be 20. If you don't multiply by the same number, it's not equivalent. It's just, what would you do here? Any ideas? Let's change it to an improper fraction. So the same thing is -9 for us, right? So what would that be over 12? What did you have to multiply 4 by to get 12 would be 3, right? So as long as you multiply the top by 3 also, what would the numerator, what would you get then? It would be -27, right? -27 over 12 is the answer. Here's a little harder one. We got 4 over 9y and we equals -12x over something. So the question is, what did you multiply 4 by to get -12x? How about -3x, right? -3x. So if you multiply the bottom by -3x, it should be equivalent. So what does the bottom have to be? -27xy, isn't that right? So that's how it works. Okay, let's do a couple more and then I'll give you something to try. Like I've been saying the whole time though, you're welcome to hit the pause button whenever you want. How would you make this into a true closed sentence? What did you multiply 3 by to get 12? 4. So this is where it gets a little tricky. Look, you have to multiply the top by 4. Does the 4 multiply the x? Does it multiply the 5? Which one does it multiply? And the answer is, it multiplies the whole top. So what is 4 times the quantity x plus 5? You could leave it like that, or you could just write it as 4x plus 20, you see? But when you multiply the top by 4, you better multiply the whole thing. So there's really parentheses around there. In fact, there's parentheses around the bottom too. You don't really need them, but there's always parentheses around the whole top and the whole bottom. All right, what's the trick on this one? 3 over 1. So what did you multiply 3 by to get that? What do you multiply 3 by to get 3x plus 3y? If you think about what we just did, wouldn't it be x plus y? Isn't that what you multiply the top by? So if you multiply the bottom by x plus y, what is x plus y times 1? It'd be x plus y. Okay, why don't you try a couple here? Go ahead, hit the pause button and try these. Just be sure to multiply top and bottom by the same number. Okay, on the first one, what did you multiply 3 by to get 15x? It'd have to be like, what, 5x. So multiply the top by 5x too, and it gives you a 5x times 2 is 10x. Don't forget the x. On this one, what did you multiply 4 by to get x plus 8? What did you get multiply 4 by to get 4x plus 8? It would have to be x plus 2, wouldn't it? So multiply the bottom by x plus 2. 9 times the quantity x plus 2 would be, what, 9x plus 18? Is that right? Okay. Anyway, so what we're really after here is being able to take fractions and write them differently using equivalent fractions that are equal but look different. One question would be, why are we doing this? I thought you just got through telling us we're supposed to simplify our answers. Well, the answer is there are sometimes, especially when we start adding fractions later, that you have to make the fractions with the same denominator. So you may have to change the way the fractions look. And the way you do that is by using equivalent fractions, okay? So anyway, if you want to find 3 fractions that are equivalent to 5, 6, the answer is just multiply top and bottom by the same number. Like, what if you multiply top and bottom by 2? That would be 10 over 12, right? Now, another one, well, let's multiply top and bottom by 3, but go back to this one now. Multiply top and bottom by 3. See what it's going to be? Top and bottom by 3 would be 15 over 18, right? And here we're going to multiply top and bottom by 5, let's say. It would be 25 over 30, so that's how it works. Get the idea? Now this one, find 3 equivalent fractions. Let's multiply top and bottom by 2. Let's see, 2 times 3 is 6. What's 2 times negative x? Negative 2x. Let's multiply top and bottom by 5. You'd get 15. What's negative x times 5? It'd be negative 5x. And one more. What would you multiply top and bottom by 3? So that'd be 9 on the bottom. What do you get when you multiply the top by 3? Negative 3x. There's lots of answers. So your answers on the homework might look different than the ones in the book. Okay, go ahead, hit the pause button, and we'll go over these in just a minute. The instructions are find 3 fractions that are equivalent. Okay, so here we go. 4, did you think of it as 4 over 1? That helps, doesn't it? So let's multiply top and bottom by 2, so you get 8 over 2, or top and bottom by 3. Go back to the first one. You'd get 12 over 3. If you multiply top and bottom by 4, you get 16 over 4. But there's lots of other answers. These 3 fractions are all equivalent to 4, all right? This one's a little harder, I think. If you multiply top and bottom by 2, the bottom becomes a 6, but the top, you better multiply the whole numerator by 2, okay? So that becomes 2x minus 4 would be 1. If you multiply top and bottom by 3, the bottom by 3 gives you 9, but the top, you got to multiply the whole expression by 3. So you get 3x minus 6 over 9. Last one, if you multiply the bottom by 4, you got to multiply the top by 4, and your answer should be 4x minus 8 over 12. Of course, there's other possibilities. All right, so next time we'll start talking about adding fractions.